Welcome to Special Product Formulas. Certain types of products occur so frequently that you should memorize them. You can verify the following formulas by performing the multiplications. Right? And we can do that if you'd like. So let's look at the first one. So we have a plus b times a minus b, a sum and difference of the same terms. So if we were to multiply those together, and you don't have to write this part down, I'll put it up here and then I'll erase it because I'm going to run out of space. So if I had a plus b times a minus b, right, and if I'm going to use distribution, I'd have a times a minus b. That thing's an A. It doesn't look any better. Plus b times a minus b. A times a would be a squared. A times negative b is negative ab. B times a, whether I write it ba or I write it ab, it's the same thing. And b times negative b would be negative b squared. So you notice that those middle terms, AB, negative AB and positive AB, those would cancel each other out, and we have a squared minus b squared. So if you're multiplying two expressions and they are a sum and a difference using the exact same terms, then you will end up with the first value, a squared, and the second value, b minus b squared. And if you think backwards, if this is a difference of squares, if we were factoring it, we'd have square root plus square root times square root minus square root. Right? So if we were factoring, we'd end up with that. Let's look at the second one. All right, so we have a plus b squared, so we have a square of a sum. All right, so if I have a plus b squared, that's a plus b times a plus b. And so if I'm multiplying using distribution, I'd have a times a plus b and b times a plus b. A times a is a squared. A times b would be ab. B times a is the same as a times b, right, ab. And b times b is b squared. So notice we could combine like terms. A squared plus ab would be 2ab plus b squared. So a little shortcut, if you see you have a something squared, you're going to have the first one squared plus 2 times those the product of those two values plus the second one squared. Right? And that's a little shortcut if you have a square of a sum. And you'll get to see this on the next page with numbers. All right, let's look at the next one. What if we have a square of a difference? All right, so we have a minus b squared is the same as a minus b times a minus b. All right, and using distribution, that would be a times a minus b plus a negative b times a minus b, right? We distribute both the a and the negative b to the a minus b. A times a would be a squared. A times negative b would be negative, oops, let me write it alphabetical. It would be negative ab, just because it looks nicer. Negative b times a is still negative ab, and negative b times negative b is a positive b squared. So notice you get the very same thing as a sum of squares, except your middle term is now negative, and that makes sense. Right, so a little shortcut for a sum of a difference, right? You're going to have the first one squared minus 2 times the product of those two values in that binomial plus the second one squared. Let's look at cubes. Right, we have a plus b cubed. All right, so if we have a plus b cubed, that would be a plus b times a plus b times a plus b. All right? Let's take care of the first two first. All right? Actually, let's take care of the last two first. So we have an a times a plus b. And now we would multiply a times the second one, or the third one, a plus b times a plus b. All right, so I'm kind of ignoring that first a plus b for the moment, and I'm just multiplying these two together using distribution. So I'm distributing the a to the a plus b and the b to the a plus b. And that gives us a plus b times a would be a squared, plus a times b would be ab, plus b times a, or a times b, it's going to be ab, and b times b would be b squared. And we could combine the like terms, and that would give us, I'll just come over here. That would give us a plus b, that first one that we did nothing with, and then a squared, ab plus ab, hey, that's 2ab. Well, of course it's 2ab because we have a sum of squares. And then plus b squared. We would do the same thing, distribution, but with the a plus b now. So we would have a times a squared plus, I'm going to erase this over here because I'm running out of space. Oops. Well, I guess it doesn't want to move. There it goes. All right, there we go. All right, so we have the a times a squared plus 2ab plus b squared, plus the b times a squared plus 2ab plus b squared. All right, so a times a squared would be a cubed. A times 2ab, that would be 2. A times a would be a squared, right, and then times b. Right, because we can, when we multiply like bases raised to a power, we add the exponent, so this is now going to have a square on the a. A times b squared would be a b squared. B times a squared would be a squared b. B times 2ab would be 2ab squared, just adding the exponents. And b times b squared would be b cubed. And notice we have some like terms. Right? We have a squared b and another a squared b. We also have a ab squared and another ab squared. All right, so we have a cubed, 2a squared b plus another a squared b would be 3a squared b. ab squared plus a 2ab squared would be 3ab squared. And just a b cubed. And there we go. Now there is another way that you could get those coefficients. And so, by the way, if we, it took a little while to do that one, maybe we'll skip the a minus b cubed. So you're just going to have, this going to be exactly the same, except we're going to have one negative. And why would we have one negative? Actually, let's just do, we'll do it, but I'll do a shortcut. So if I have a minus b times a minus b times a minus b, remember this part here would be this part here, right? We've got a square of a difference. So this would be a minus b times a squared minus 2ab plus b squared. So now when we go and multiply, if we're going to end up with one of our values being negative. Let's just take a look at that one. So we have a times a squared minus 2ab plus b squared. I don't know why I'm even looking. Minus b, or plus a negative b, times a squared minus 2ab plus b squared. So when we go to distribute, we still have the a cubed. A times negative 2ab would be negative 2a squared b. A times b squared would be a positive ab squared. And then negative b times a squared would be a negative a squared b. Oh, hope I can fit that in. And negative b times negative 2ab would be a positive 2ab squared. And then we have negative b times b cubed, b squared is going to be a negative b cubed. So you can see, well, except for the last term, which went right off the screen, you can see because of the difference in the sign for that middle term, we're going to end up with some negative values. There we go. And so we have a cubed, negative 2a squared b, another negative a squared b, so that's going to be minus 3a squared b, and ab squared plus a 2ab squared, that's going to be a 3ab squared, and then we have a minus b cubed. So notice we kind of have like a positive, a negative, a positive, a negative, so that's a way you can remember it. So here I just showed you, yep, these formulas work. And by the way, if you know Pascal's triangle, the coefficients when you're cubing or raising to the 4th power, to the 5th power, or whatever power, you can find those using Pascal's triangle. I'll show that to you a little later on, and that might be useful. But for right now, I'm just going to ask you to learn a couple easy, handy-dandy special product formulas that you can use to find some products. So you didn't need to write any of this out. I just wanted to show you that, yes, these really work. Now let's do a couple problems. So we're going to do 4 problems together. These 2 are in your notes. There are 2 more that are not in your notes, but I want you to put them in your notes. Okay? So let's use, and we'll write down the rule, and then we'll use that rule. So these are going to be quick. We're not going to be expanded out, but it's nice if I can show you a shorter way. So we have 3x plus 5 squared. I have a sum of squares. All right, so remember it's going to be a squared plus 2ab plus b squared. And if you forget, hey, you can turn to your notes over here and take a look at that, right, to remind yourself. All right, so what's a, what's b? So a is the 3x, and b is the 5. All right, so that means this is going to be 3x all squared plus 2 times 3x times 5. Oops, that's what happened to my parentheses. Times 5, and then plus 5 squared. So the a is the first term in the binomial, and the b is the second term in the binomial. 3x squared would be 9x squared. 2 times 3x times 5, that's going to be 30x. And then 5 squared is 25. And there we go. That's all there is to it. All right, now I'm not going to prove this is so by expanding it, because I proved it with the formulas on the other page. Now we can just use it. Let's look at the second one. X squared minus 2 all cubed. All right, so if you forget, you can always come back here, look at your rule. All right, we've got a cubed minus 3a squared b plus 3ab squared minus b cubed. Notice I pointed out the signs, but I didn't point out the exponents. Notice how the exponents are changing. All right, and notice that our a is cubed, but then look at what happens. On the next term, it goes down 1. All right, so it's decreasing. And guess what? Now it's a 1. And guess what now it is? Now it's a 0. So as one of the the exponents on one term are decreasing, notice what's happening to the exponents on the other term. Well, you can think of this one here as b to the 0 power. All right, so first it's b to the 0 power, and then it's b to the first power, and then it's b squared, and then it's b cubed. So how you can remember this is that your exponent on one term is increasing. Your exponent on the other term is, your exponent on your first term is increasing. The exponent on that second term is decreasing. Okay? So now let's write that out. All right, so we have x squared minus 2 cubed. All right, so our pattern is going to be a cubed, and then you can also think of it as a cubed b to the 0. That's the way you can think of it, minus 3a squared b to the first plus 3a to the first b squared minus a to the 0 b cubed. If you think it like that, you probably will never forget the terms in that. Now what's our a and what's our b? Our a is the x squared, right? The x squared. And the b is the 2, right? The negative, that's just our difference of cubes. Or excuse me, our cube of a difference. Excuse me, the other way around. Cube of a difference. All right, so now let's just plug that in. All right, so we have x squared cubed, and then 2 to the 0 power, minus, and I'm going to write it out like that just so that you can remember how the exponent on one term is increasing and the exponent on the other value is decreasing. All right, and then we have minus 3, and then x squared squared, and 2 to the first power, plus 3 times x squared, because now it's just, and that's to the first power now, right? Because that one is decreasing, and now this one is, power is increasing. And I need like a tad more space. I think I write too big. And then our last one, so then we have minus, and now it's going to be x squared, but to the 0 power, and 2, that's a 2 cubed. So each time the exponent on one is increasing and the exponent on the other is decreasing. And notice it goes positive, negative, and we have a coefficient of 1, and then 3, and 3, and 1. All right, so now if we simplify it, this will be x to the 6 times, well, anything to the 0 is 1, minus 3 times, we got, well, let's combine those. We got 3 times 2. Actually, I'll just write everything. I'll simplify and then we'll multiply. So we have 3. X squared squared would be x to the 4th. And then we have 2 to the 1st. So that's just 2. And then we have 3. We have just x squared because it's to the first power. And then we have 2 squared, so that's going to be 4. And then we have, that's a 0. That looks almost like a 6. And then we have x squared, but to the 0 power, well, that's 1. And then 2 cubed, that's going to be 8. So now let's just simplify that out. So that's going to be x to the 6th minus 6x to the 4th plus 12x squared minus 8. And there we go. All right? And see how much easier that was. Now it took us a little time, but now how long will it take you when you get the pattern down, right? It's not going to take you long at all. You saw how little we had to write. Right? All right, let's do 2 more examples, and these are 2 I want you to add to your notes, the last 2. All right, so we're going to do these the same way. We've got a, now we might look at it and go, there's radicals. Oh no, but what is that? That's just a, we've got a difference. We got the same terms, but notice the sign changed. All right, so we've got a product, a sum and difference of the same terms. Didn't really have a fancy name, did it? So we have a plus b times a minus b. Remember, the middle terms will drop out. It's just going to be a squared minus b squared. So that's going to be super easy. So our pattern here is a squared minus b squared, right? Because even if you think of FOIL, you're going to have 2x times a negative square root of y and a 2x times a positive square root of y. Those would be opposites. What's our a? Our a is 2x. What's our b? Our b is the square root of y. So that's going to be 2x all squared minus the square root of y all squared. 2x squared is 4x squared. And the square root of y squared, and square root cancel, minus y. And there we go. We're done.